Hello everyone, in this video I'm going to teach you about what is waveguide and what are the different types of waveguides and why we are using waveguides instead of coaxial cables or the transmission lines. Okay, first let's see what is waveguide. A waveguide is nothing but a hollow metallic tube. Okay, it's a hollow metallic tube for transmitting the high frequency electromagnetic waves. Okay, here remember, simply a waveguide is nothing but it's a hollow metallic tube used to transmit the high frequency electromagnetic wave. And why we are using these waveguides instead of transmission line means, let's see here, at high frequencies than 3 gigahertz, transmission of electromagnetic waves along transmission lines and cables are more difficult, mainly due to the losses that occurs both in solid dielectric needed to support conductor and in conductor themselves, which means at the higher frequencies, that means when frequency of the electromagnetic wave is more than the 3 gigahertz, then these transmission lines and the coaxial cables are not support. That means these are not capable of transmitting the signal as it is. It may lose, the signal may lose while transmitting through the coaxial cables or the transmission lines while its frequency is more than the 3 gigahertz. That's why we move to the waveguides for transmitting high frequency signals, nothing but the microwave signals. Okay, and the tube used to transmit that high frequency electromagnetic wave is known as waveguide. Okay, remember this. And they are used in ultra high frequency and microwave region as an alternative to transmission lines. I already told you these waveguides are used for transmission of ultra high frequency waves and microwaves as an alternative to transmission line means instead of transmission lines, here we are using the waveguides for ultra high frequencies and microwaves. It may be noted that no TEM wave can exist in waveguide, but TE and TM waves can exist. It means we know in free space we transmit the TEM waves. TEM wave is nothing but transfer electromagnetic waves, which means here the electric field and magnetic field are perpendicular to the propagation direction. Okay, here the electric field and magnetic field are perpendicular to the propagation direction, but TE wave and in TM wave only either electric or magnetic fields are exist which are propagating perpendicular to the propagating direction. Okay, here the waveguides doesn't support the TEM wave. Remember this point also, it's very important. And one more thing is, induced currents in the walls of waveguides give rise to power loss, and to minimize these losses the waveguide wall's resistance is made as low as possible. Okay, here we know the waveguide is nothing but hollow metallic tube. It's like a tube structure. When we are transmitting the electromagnetic waves through the tube, okay, through the tube, these electromagnetic waves may strike the walls of the tube. Okay, due to the irregularities or the resistance of the walls of the tube, we can reduce or we may lose the power of the electromagnetic wave. To reduce that loss, we need to coat our walls of waveguide with gold or silver. Remember this, here observe. Hence the inner surface of the waveguide usually coated with either gold or silver to improve the conductivity and minimize the losses. Okay, to improve the conductivity and minimize the losses, we need to coat uh, the waveguide with gold or silver polish. Okay, and next one is, the waveguides are generally air filled. They are superior to the coaxial cables at ultra high frequencies, and high frequencies can handle greater power and possess less resistance. Okay, so also we know these waveguides are filled by air or any dielectric medium. Okay, these waveguides are just empty, filled with air, or in sometimes we fill it with some other dielectric mediums for some other purposes, and these are the superior than the coaxial cables in terms of the ultra high frequencies. At the ultra high frequencies, these waveguides are more superior than all other the transmission lines. Okay, and this is about the waveguides. And now I'm going to teach you what are the different types of waveguides we have. Let's see here. Mainly we have two types of waveguides. One is rectangular waveguide and another one is circular waveguide. As the name indicates, rectangular means here the shape of the waveguide is in the rectangle shape. Okay, shape of the waveguide is rectangle shape, and circular waveguide means here the shape is the circular shape. For rectangular waveguide, here let's see, it's a top view of rectangular waveguide. It's the top view of rectangular waveguide, and it's the front view of I think circular waveguide. Let's see here, it is the side view of rectangular waveguide. Let's see here, the rectangular waveguide has a breadth A, length D, and width B. These are the three parameters we need to consider while transmitting the electromagnetic waves through the rectangular waveguide. And when we are transmitting our electromagnetic wave through the circular waveguide, we need to consider the radius of the waveguide. Okay, now let's see, it is the elliptical. Okay, it's a elliptical waveguide. Sometimes we are using this type of structures also. Mostly we are using in most of the laboratories and the practical purposes also, we are using only rectangular and circular waveguides. Here it is the elliptical waveguides, and these two are rigid waveguides. It is a single rigid waveguide and it is the double rigid waveguides. These are also used in some other applications based on their uses. Okay, and this is about the types of waveguides. I hope you understood this topic. Thank you for watching this video.